Okay, let's keep going. So let me get my pen. Why it doesn't work? Oh, it works now. Okay, let this go away. Okay, so let's look at 27. So we want to add, subtract, multiply, divide rational expressions and simplify the answer. So A, we have two rational expressions, right? This one and this one. And we want to add them. Remember, when we add two fractions, we need a common denominator. Right? So we want to put this denominator and this denominator into factored form. That's how we try to make a common denominator. So x squared plus x minus 6 can be factored as x plus 3 times x minus 2. Right? You see x times x squared, 3 times -2, -6. How do we get the middle term? The middle term comes from multiplying these two, 3x, multiply these two, -2x, add together, we get positive x. So the numerator is a 3x. So we put in a factored form whenever we want to add or subtract two rational expressions. And the second one, the numerator is x plus 3. The denominator also can be factored. It's a perfect square. It's x minus 2 times x minus 2, or we can write it as x minus 2 squared. So now what's the common denominator, least common denominator? We want to find the smallest common denominator of those two denominators. So with the first one, missing x minus 2. And second one, missing x plus 3. So the least common denominator, let me write here. Least common denominator, we use the letter LCM to represent. That's x plus 3 times x minus 2 squared. So the first one, we would multiply 1. You know, whenever we want to change the denominator, we always multiply by the transformer 1. I like to call it transformer because it's just something divides itself. So in this case, this 1 is x minus 2 divides x minus 2. And the second one, we're missing x plus 3. So we multiply 1 again, but the 1 in this case it transforms to x plus 3 divides itself. Right, so the numerator will have x plus 3 times x plus 3, that's just x plus 3 squared. Now we have common denominator, right? So we can perform the addition to the numerator. The numerator, let me write here. So we have a 3x squared minus 6, then plus x plus 3 squared, perfect square, that's x squared plus 6x plus 9. Then over the common denominator. I'm going to write LCM here, okay? So you know what I mean. LCM is x plus 3 times x minus 2 squared. So let's simplify the numerator. So 3x squared plus x squared, that becomes 4x squared. This is number 4. The denominator is still LCM, right? Then for x term, we'll have a plus 6x. For the constant, we have a -6 plus 9, which is plus 3. Okay, so this one is not factorable. So how can I tell the numerator is not factorable? Because the factors of the leading coefficient is 4. The constant is 3 times 4 is 12. And every one is positive. So that means I can only, if I have factors, I can only have positive factors. But the factors of 4 and the 3, it won't add up to 6. So that's it. That's our answer. The least common denominator means x plus 3 times x minus 2 squared. Right, so we have combined those two rational expressions into one, into this one. So we need a common denominator. And then we perform the addition in terms of the numerators. Okay, that's A. Let's say B. B, we want to divide, right? Whenever we divide by a rational expression or a fraction, we want to change to be multiplication. Then we flip over the numerator and the denominator of the second one, the divisor. And again, we want to put the polynomials into factored form. So we're looking for the common factor in the numerator and in the denominator, so we can perform cancellation. Basically, the idea is whenever we find a factor in the numerator and the same factor in the denominator, they're always equals to 1. So let's see this one. We have x to the fourth power minus 9x squared. And I can write this way. I can write it as x squared. It's still x to the fourth power, right? And the 9x squared, I can write it as a 3x parentheses squared. Now I have a difference of two squares. Difference of two squares. I can factor this as x squared plus 3x times x squared minus 3x. Difference of two squares. Then the denominator, I have x squared minus 4x plus 3 can be factored as x minus 1, x minus 3. Right? I should write here actually. X minus 1 times x minus 3. You see -1 times -3 give us a positive 3. Then -1x plus -3x give us the middle term -4x. Then this one multiply by, change division into multiplication, flip over the numerator and denominator of the divisor. So x squared minus 16 now becomes the numerator. And it's a difference of two squares again, because 16 is 4 squared. So x squared minus 16 can be factored as x plus 4 times x minus 4. The numerator before now becomes the denominator. So x to the fourth power plus 2x cubed minus 8x squared. So those three terms has a common factor of x squared. So let's factor out x squared first. Then x to the fourth power inside the parentheses becomes x squared, then plus 2x minus 8. And let's try to factor this. X squared plus 2x minus 8. So this can be factored as x plus 4 times x minus 2. 4 times -2 give us back -8. Then we'll have 4x times -4x and -2x adds up to be the middle term 2x. And of course, we have x squared here. And the numerator is x plus 4, x minus 4. X plus 4, x minus 4. Do you see a common factor already? You see the numerator will have x plus 4, the denominator will have x plus 4. So something divides itself becomes 1. And 1 in the factored form doesn't contribute anything, so we can ignore it. So this one becomes x minus 4 divided by x squared times x minus 2. Right. So now let's write together. So before, right, let's look at this one. We have this one multiply this one. It was a dividing, but we change to be multiplication. We flip over the second rational expression. Do we have common factors? Not really. So what do? We just write it out. So we have x squared plus 3x in the numerator. We have x squared minus 3x in the numerator. We have x minus 4 from the second rational expression. And then all divided by how many factors we have? We have x squared in the denominator. We have x minus 1 in the denominator. We have x minus 2 in the denominator. We have x minus 3 in the denominator. Oh, there's one more common factor. I don't know if you see it. Look at this one. This one is x squared minus 3x. So I can factor out x from there. If I factor out x, so x squared becomes x. 3x becomes 3. Now you see this one and this one cancel to be 1, right? So what's left? So the answer is, oh, also x term. X cancels with this x squared. So our final answer is, and this one also has a common factor of x. So I can factor out the x times x plus 3 times x minus 4 in the numerator, and in the denominator, I also have x, right? X times x minus 1, x minus 2. And these two x canceled. X divided by x becomes 1. So in the end, I'm left with x plus 3 times x minus 4 divided by x minus 1 divided by x minus 2. Okay, that's our final answer for 27B. Now I need to erase this to go to 28. I need to go to my eraser. Okay. Yeah, I haven't found the button to erase them all at once yet. Zoom is more convenient in this feature. Zoom has a clear everything button. So I click once, everything disappears. Okay, let's see 28. I need to erase more. Okay, let's see 28. Let me go back to our pen. Hello. All right, 28. So we have a couple. Please come down, come down. Okay. You see, we have 4 layers of fractions. So the numerator I have x over x plus 3. The denominator I have x over x plus 3 plus x. So, you know, there are different things we can do. What's going on? It doesn't move anymore. Why my pencil doesn't move? Okay. Okay, because my computer is on the top of my joint tablet. Come on, what's going on? Okay. The different ways we can do this. So one way is probably I'm going to multiply by x plus 3 divide by x plus 3. You see, so this is 1, right? So that's why I like to call 1 transformer. 1 can be anything divides itself. The key on the shelf.
I'm gonna take it, okay?
Yeah, I'm not going out. Okay, so I multiply by 1, nothing gets changed. So that's perfectly fine. So I want to multiply the numerator. The numerator is x over x plus 3 by x plus 3. I want to multiply the denominator by x plus 3 as well. So what do we get? You see in here, the x plus 3 is a denominator, right? In the denominator. But when I multiply this x plus 3, this is the numerator. So actually, let me just write it out once. So when I multiply x plus 3 multiplied to the numerator, x, then the denominator, I have x over x plus 3 multiplied by x plus 3. But in the denominator, I have 2 terms, right? I have another term of x, and x needs to multiply by x plus 3 as well. Okay, make sure this step makes sense for you, okay? Make sure this step makes sense for you. So when I do this, let me change my color to be red. You see, I have a common factor in the numerator, in the denominator, that becomes 1. So the numerator now, I'm left only with x. The denominator, you see this x plus 3 is a numerator. So x plus 3 over x plus 3 becomes 1 again. So I'm left with x in the denominator. Now the second term, I have more. I have x times x plus 3. So that gives me x times x, that's x squared. X times 3, usually we write 3 before the variables. So just by convention, mathematics has a lot of conventions. Just by convention, we write the number before the variable, right? So let's simplify this a little bit. So the numerator I only have x. The denominator I have leading term x squared, then x plus 3x, that's 4x. So by now, are we done? No, not yet. We see the common factor of x, okay? So we divide every term by x. Numerator divided by x, I have 1. X squared divided by x, I have x. 4x divided by x, 4. So the final answer is this, 1 over x plus 4. Okay, let's see 29. 29, we want to divide this by short division or long division. Okay, let's use this. The first one, let's perform just division. Because why? Because this is a monomial, right? Just everyone. So this term divided by this. Well, 12 divided by 3. So let me write here. 12 divided by 3, that's a 4. X to the 4th power divided by x squared, that's x squared. Y to the 8th power divided by y, that's y to the 7th power. When we divide the same base, we subtract the exponents. That's not the second term. Second term is negative. The divisor is positive, so we get a negative term. 9x cubed, y to the 5th power divided by this. 9 divided by 3, I get 3. X to the 3rd power divided by x squared, I get x. Y to the 5th power divided by y, I get y to the 4th power. Then the third term is positive. Positive divided by positive is positive. 3 divided by 3 is 1. I don't need to write it for now. X squared divided by x squared is 1. So 1 times 1. I have y squared divided by y. So which is just y. I have 1 times 1 times 1 times y. That's just y. So last term, I have negative 3. Negative divided by positive, I get negative. 3 divided by 3, that's 1. X divided by x squared. Okay, be careful with this. X divided by x squared. That's 1 over x. Okay, so I have 1 over x. Then y squared, no, not y squared. Y divided by y is 1. So 1 over x multiplied by 1, still 1 over x. So in the multiplication, when we multiply by 1, we can ignore it. And that's it. So this is the answer for 29B. For 29A, sorry, not for 29B. I'm going ahead of myself. Now B, let's try short division. Right, short division. So what do we do with short division? We're going to make this symbol and write down only the coefficient. So we don't want to write the variables. We want to write the coefficient. So the coefficient of x cubed is 1. Coefficient of x squared is negative 12. Coefficient of x, there's no x in there. So the coefficient is 0 because 0 multiplied by anything is 0. Then the constant term. So we have to make this by order, okay? The first one is x to the 4th power. So the second one, x to the 3rd power. No, x to the 3rd power. So x to the 3rd power, the first one, the negative 12 is x squared. 0 is for x. Negative 42 is a constant. And here we have x minus 3. So if it's x minus 3, we're going to put a positive 3 here. Now remember, what do we do with short division? First, we write down this number. Whatever this number is, we put down here. Now we use this number multiplied by 3. 1 times 3 is 3. So we're going to put 3 down under negative 12. Then we add those two numbers. Negative 12 plus 3, negative 9. Then we use this negative 9 multiplied by 3. We get negative 27. We add with 0. We still get negative 27. Then we multiply negative 27 with 3. So negative 27 times 3, what is it? 81. Negative 81. Then we add those two numbers. We add those two numbers, what do we get? We get a negative 123. So what does this represent? This represents x squared minus 9x minus 27, and with the remainder of 123 divided by x minus 3. All right, so this is the answer for, for this one. So which means, you see we have a remainder, negative 123, which means x minus 3 is not a factor of the dividend x cubed minus 12x squared minus 42. Okay, let's see 30. We're going to solve rational equations. Also, we need, when we deal with the equations, actually it's easier. Because it's an equation, we can always multiply, divide, subtract, add the same thing, same number, or perform the same operation on both sides simultaneously, because it's an equation. As long as we do equal things on both sides, we're fine. You know, we keep the equation. So for this, you see x minus 5, x plus 2. If we multiply those two, what do we get? We get x squared minus 3x minus 10, which is this. So that means this one can be factored as x minus 5 and x plus 2. So one way we could do is we just do this. We use this x. So the first one, we multiply x plus 2 over x plus 2. Then just plus 3 times x minus 5 over x minus 5. Once we have a common denominator, we just perform the addition in terms of numerators. So let's simplify the numerator. I have 3x here. No, not 3x. I have x squared plus 2x plus 3x minus 15. Right. Then divided by x minus 5 times x plus 2. And this one is the same as on the other side, x squared minus 3x minus 10. So if I have a fraction, the denominators are the same. That means the numerator have to be the same. So I can ignore the denominator, just calculate the numerators. So the numerators, let me erase something. Let me erase here so I can. Back to my pen. So I ignore the denominator because I have the both sides of the denominators are the same. I just combine the numerators. So on the left-hand side, I have x squared. Then I have 2x plus 3x. That gives me 5x. Then minus 15 equals to 7x. Quadratic equation. So I want to move 7x to this side. I have x squared plus 5x minus 7x minus 15 equals to 0. Or you could think subtracting negative 7x on both sides, right? So simplify this, I get x squared minus 2x, because 5x minus 7x becomes negative 2x minus 15 equals 0. And this is factorable, right? I can factor as x minus 5, x plus 3. Because you see, minus 5 plus 3, that's negative 2. That's how I get my middle term. So that gives me two solutions. X minus 5 can be 0. X plus 3 can be 0 by 0 property. Then x can be 5. X can be negative 3. So I have two solutions for 38. One is 5. Another one is negative 3. Now let's see 31. 31 is a little bit tricky. But sometimes when we see the word solving, we think we can get a value. Not necessarily. But solving this case means we want to isolate So we solve formula for the specified variable, which is solve for R. So which means we want to single out R by itself on the right-hand side. Then legally move every term to the other side, to the right-hand side. All right, so first step, what do? We think this I is I over 1. Then we can perform something called cross multiplication. We multiply E with 1, we get E. We multiply I with R plus little r. So I times capital R plus lowercase r. Then, because we're solving for r, this little r, maybe we want to divide I on both sides. So we get e to the I, we get not e to the I, e divided by I equals to r plus r. Because we want to single out little r, so we want to subtract r to the other side. We'll move r to the other side, so we get e divided by r, I subtract r equals to little r. So little r is solved. So in this case, see, every term is a variable. Solve for a specific variable means to isolate the variable all by itself. So r equals to e divided by I minus r. Okay, now let's see 32. So we want to use rational equations for live applications. Let's see example 8. So a laptop manufacturer spends $6,000 for facilities per month. So this cost is per month. So we gotta pay attention to the unit. And it costs $50 to produce each laptop. So this tells us 50 is a rate of change. If it's one laptop, it costs $50. If it's 2 laptops, it costs $100. 3 laptops, so $150. So this is a rate of change. It depends on how many laptops. The cost of this depends on how many laptops being produced. So the question is, how many laptops must a manufacturer produce each month to have an average cost per unit of $80? Okay, so we need to make an equation. So this equation on one side says, okay, I have a $6,000 overhead for the business to produce laptops. How many laptops? Let's call L many. Let's name the variable L. Let's see, we have to make L many laptops, okay, to make the average cost per unit for $80. So one way to calculate the cost is the $60,000 per monthly. So this is the overhead, fixed cost. So this is the fixed constant plus 50 times L. So each laptop costs $50 and L many laptops cost 50 times L dollars. That equals to average of 80. So which means average this $60,000 overhead into each laptop. So each laptop before was $50 per one. Now add the cost, add the business overhead is $80 per laptop. We're still talking about the L many laptops. So linear equation, right? So how do we solve this? 50L, we move to the other side, become subtract 50L, or you can think subtracting 50L on both sides. So this side becomes 0. 80L minus 50L, we have 30L equals to 6,000. We divide by 30 on both sides because we want to get a 1L. And the 1L, we don't bother to write the 1 in front of L. So 60 divided by 30, 200. So the manufacturer have to produce 200 laptops to make the average cost of $80 each laptop. Okay, let's see B. Jane can clean the house in 8 hours. So this is work done problem. When she works with Mike they do the job in 6 hours. How long will it take Mike to clean the house all by himself? Remember we said work done can be any number, but in the end it gets canceled, so we just call the work done 1. So the speed of Jane is the work done divided by 8 hours. So that's Jane's speed, 1/8. What's Mike's speed? We have no idea. So we use 1, maybe 1/m. So that's Mike's speed. So it takes Mike m hours to finish the job all by himself. But if they work together, that means add the two speed up, right? So the rate of change for the speed for Jane is 1/8. The speed of Mike is 1/m. Add up means they work together. How long take them to work together? 1/6. 6 hours. So the speed is 1/6. So you see we have made linear equation, rational equation. So we want to solve for m. So what do? We just subtract 1/8 on both sides. Subtract 1/8, right? So 1/m equals to 1/6 minus 1/8. So how do we make this subtraction of fractions? We can do this. Multiply 1 with 8, that's just 8. Multiply 1 with 6, that's a 6. Perform the operation subtraction. That's a numerator. Denominator, we just multiply these two. So 1 over, oops, let me write up here. 1/m equals to 8 minus 6, that's 2. Divided by 6 times 8, 48. Divided by 2 in the numerator, in denominator, we get 1/24. So the speed of Mike when he worked with himself, when he worked by himself is 1/24. But the question, what's the question asking? The question is asking how long will it take for Mike to clean? So these hours, so how many hours? 24 hours, right? Because this question is not ask how fast, what is the speed of Mike? It asks for the time, so it's 24. So it takes Mike 24 hours to clean the room all by himself. Now let's see C. Gary rides the bicycle 7 miles per hour, speed, right? Rate of change, miles per hour. So miles in the numerator, hours in the denominator. Slower than Carrie. So comparing those two speed. In the time it takes Gary to bicycle 45 miles, Carrie can travel 66 miles. So given the distance, so the question is asking how fast does Gary bike? So it's asking Gary's speed. So we have this formula, distance equals the speed multiplied by time. All right. So Gary bicycle 45 miles. Let's see Gary, this is for Gary, for G. 45, how long it takes him? Gary, we don't know. Let's see, it takes G hours. Well, what's Gary's speed? We don't really know Gary's speed yet. Well, let's call something else. Okay, let's call Gary's speed G. Let's call the time he needs is a TG. Okay, with a little foot G here. And his speed G multiplied by the time he needs give us the distance 45 miles. For Carrie, let me write here. For Carrie, travels 66 miles. So for Carrie, what's Carrie's speed? We don't know. Let's call C. What's Carrie's time? Did they say Gary rides back to 7 miles per hour slower? No, we don't know yet. Let's call it TC. So we have 4 variables in this case. Let me erase something so I can have more space. Oh, actually, I could move this. Yeah. Let me work down here. So we have the relation about the speed of Carrie and Gary. Remember, I call Gary speed G. I call Carrie speed C. So Gary rides a bicycle 7 miles slower than Carrie. That's C minus 7. So I have this relation. So speed of Gary and speed of Carrie. So Gary is slower because he rides 7 miles per hour slower than Carrie. So I get a G equals to C minus 7. So now what else do I given? Same time. Do you see here? It said, in the time it takes Gary to bicycle 45 miles, Carrie can travel 66 miles. That means those two times the same, can only use one t. We don't need to differentiate as a tg, tc anymore. In the same time, one finishes 45 miles, another one finishes 66 miles. So we have these three equations to work with. So this one tells us G equals C minus 7. And then we have this 45 miles. We could use this T because the T equals each other. So this one give us 45 over G, right? That's T. And this T is 66 miles over C. All right, let's write down here. So we have G equals C minus 7. We also have 45 over G. That's the time Gary takes Gary, and the time takes Carrie is the same, is 66 over C. Okay, we have system of two equations. We have two variables, two equations, guaranteed solvable. Okay, so this is a C. This is letter C. Now the question is asking for Gary, right? So if we're asking for Gary, what do we want to do? We want to substitute Carrie. So we want to write C equals to Gary plus 7. Right? So Carrie's speed is 7 miles per hour faster than Gary. So then what do? Then we substitute this G plus 7 into this C. So we rewrite as 45 divided by G equals to 66 divided by C, but we don't want to write C anymore because we want to get rid of C. We write it as G plus 7. Now, you see we only have one variable now. Let me change my color. We only have one variable now. So I have a fraction on the left-hand side. I have a rational expression on the right-hand side. I can perform cross multiplication and multiply those two. That has to equal to these two. Why? Think about a half equals to 3 over 6, right? I cross multiply 1 times 6 has to equal to 2 times 3. So same thing here. So that is 45 times G plus 7 equals to 66 times G. So 45G plus 45 times 7 equals to 66G. Now subtract 45G on both sides. Subtract 45G on both sides. So I have 45 times 7 equals to 66 minus 45. That's what? That's 21, isn't it? That's 21G. So 21G equals to 45 times 7. 45 I can write as 15 times 3. Then times 7 equals to 21G. 3 times 7, 21. So I divide 21 on both sides. So G equals to 15. So how fast does Gary bike? Gary bikes 15 miles per hour. 15 miles per hour. Okay, this one might be a little bit complicated. So let's go back to review what I have done. So first, I interpret the speed, right? Talking about Gary rides the bicycle 7 miles per hour slower than Carrie. So if I call the speed of Gary G, little g, I call the speed of Carrie, little c, I have this equation. G, the speed of Gary, G equals to the speed of C, Carrie, subtract 7. Then I can rewrite this equation as both sides add 7. I can see Carrie's speed equals to the Gary's speed plus 7. Now, because they use the same time, in the same time, Gary can bicycle 45 miles, right? Gary can bike 45 miles, then divided by his speed. That's the time he used. That equals to the time Carrie used. So Carrie traveled 66 miles with her speed of C, right? Same time. So I use the same time to form these two equations. Now, I have a system of two equations with two variables that are guaranteed to be solvable. I'm using substitution method because C equals 9 plus G plus 7. This is G plus 7. I substitute into this C. So C becomes G plus 7. Then I use cross multiplication, right? So I cross multiply, then I get this equation. I solve this equation. In the end, I get G equals 15. That means Gary's speed for bicycling is 15 miles per hour. All right. I need to erase. You know what? Let me take a little bit break. Then I'll start again, okay?